Today I'll be talking about some recent trends for the Lake Michigan lower trophic levels, and I'd like to thank all the agencies and partners who've helped provide information for this talk. I'll be touching base on quite a few lower food web indicators. Several of these that are highlighted here have been noted as being especially important for our understanding of forage fish production in the lake. So jumping into one of those important indicators, this is the total phosphorus in the spring. And this is from a site off Muskegon. And you can see that in the early 2000s, there was basically a regime shift. Since 2007, there's been some variation around that long-term mean, but with no real trend. And in 2024, the values for total phosphorus were just slightly above that long-term average. Next, looking at the spring total phosphorus in the nearshore, this is a much shorter time series. This is for 5 sites located between Muskegon and Grand Haven. So these sites are located in close proximity to some major sources of tributary loading. Again, just like in the offshore, we see a decline over time. But in the more recent time series, there's been no real trend. And in 2024, it was just slightly below that long-term average. Sometimes looking at just an indicator month like May doesn't really give us a full picture of what's going on in the lake. And so this is data from the offshore and the nearshore sites from December 2023 through November 2024. And you can see that the values don't really range that much over the year in the offshore site. There's a bit of a peak in June and then again in November. But in the nearshore sites, there's quite a bit of variability, and that's pretty consistent for what we see for a lot of data in the nearshore. And what really stands out was that the highest total phosphorus we saw in the nearshore was in February. If you'll recall, the winter of 23 to 24 was a winter that really wasn't. And so when we had snow, it quickly melted. And we also had a lot of rain showers instead of snow. So there was quite a bit of runoff during the winter rather than in the spring when we typically would have seen it. Next, looking at some chlorophyll. We don't have all our chlorophyll data yet because of some construction in our lab, but we do have derived chlorophyll from our fluorometers that we cast at sites. And so this is data from the offshore site for some selected months. You can see in February that chlorophyll is low and basically pretty consistent from the top to the bottom of the lake. In May, this is when we would typically see the spring bloom, and there's no indication of the spring bloom in 2024, which is consistent with the last 20 years of data, basically. For July, that's when the deep chlorophyll layer sets up, and you can see that there is a deep chlorophyll layer here. It's not all that large, but it is quite deep, around 40 meters deep. And then November, this is the month or time period in the late fall where we now typically see our highest epilymnetic chlorophyll. And you can see that that's the case certainly in these casts right here, where our highest epilymnetic chlorophyll was in the late fall rather than in the spring. Next, jumping into some zooplankton data. Zooplankton integrate a lot of factors in the food web, including temperature, bottom-up forces, and top-down forces. This data is from the summer EPA cruises, and you can see there's been a decline over time, but the last 4 years of data have fallen into what they categorize as a good biomass of zooplankton on a lake-wide basis. And you can see 3 of those 4 years we had pretty good contributions of Daphnia. Daphnia are a large zooplankton, and they're the main cladoceran that are found in the offshore regions. Again, sometimes it helps to look at the seasonal aspect as well as snapshots. And so this is seasonal zooplankton from the offshore site in the Muskegon area. On the top, we have the data for 2024, and on the bottom, the average for the previous 6 years. A couple things that stand out for 2024 was that the zooplankton biomass increased more rapidly between May and June than we typically see. And then in turn, our peak zooplankton in 24 was in August rather than later in the year in September. We also saw a pretty strong contribution of Daphnia throughout the growing season in 2024, consistent with that lake-wide summer data. Next, looking at the seasonal patterns for zooplankton in the nearshore, again, the 2024 data on top, and then the previous 6 years average on the bottom. A few things that stand out. One is our highest zooplankton biomass took place in January, which is fairly surprising to me. We also saw fairly high zooplankton biomass in January for the 1 year that we sampled in the historical time series as well. And then during the growing season, a couple of things that stand out are we saw very few veligers in 2024, and also bosmina were very low in 2024. Bosmina are a small zooplankton, and unlike the offshore, they're the main cladoceran in the nearshore areas. In addition to looking at the standing stock or the biomass of zooplankton, it can also be insightful to think about this in terms of secondary production. This is a very coarse estimate of secondary production for 2021 through 2023 based on P/B ratios and water temperatures. And we see that when we look at standing stock, copepods are the dominant component of the zooplankton community. But when we think about it in terms of secondary production, cladocerans really drive the trends in secondary production from year to year. Another thing that I want to highlight is that in the nearshore, veligers made up 23 to 49% of the annual secondary production during these 3 years. Next, looking at mysis. Mysis are a large macroinvertebrate. They're a very important food source. They're a glacial relic, and so it's important to understand what's going on with their populations. You can see there were large declines since the early 2000s. Since then, in the more recent time series, we saw some ups and downs. We had the lowest numbers in 2019. It's rebounded somewhat from there, but they do still remain at relatively low abundances at this site. Recently, mysis have been listed as a sub-indicator species for the Strait of Great Lakes report. And here you see the Michigan data along with the other lakes where we generally find mysis. In Lake Michigan, the status of mysis was defined as poor based on that huge decrease between these two time periods. And that's really in contrast with those other 3 lakes. And abundance of mysis now is more on par with what we would see in Lake Huron than what it had historically been. One of the things to keep in mind with mysis is, yes, they're a deep water species, but it seems that they're becoming even more so concentrated in the deepest water. This is some information from net tows and acoustics data compiled by the folks at Cornell. And we see that mysis are now concentrated in the deepest water. And by deepest water, I mean more than 120 meters or even greater than 160 meters, where we're finding most of the mysis in the lake are concentrated now. Another aspect to keep in mind is we've always assumed that most of the mysis are coming up off the bottom at night and are vulnerable to our net tows. I talked a little bit about this a couple years ago. We've finally got some of our methods and what we're actually sampling kind of nailed down. And what we see is that there are many large mysis that remain benthic at night. And so we may be underestimating how many mysis are in the lake simply with our net tows. And we may be especially underestimating the number of large mysis that are in the lake. And so this affects things like our egg ratio estimates and our production estimates. So this is definitely something to keep in mind and to continue looking at. This is the lake-wide trends in diparia. There really isn't any new information in these slides, although the slides have been updated to be more clear about where sampling took place. And I also just want to highlight that this survey should be taking place as part of the CSMI sampling in 2025. And so when those samples are processed, we should have an update to this map. But as you can see, diparia were once a major part of the food web, and now they're basically gone. There is sampling that takes place in southern Lake Michigan for diparia every year. And you can see again here, there are a few diparia out there, but we're talking one or less than one per square meter at these sites. So there is a remnant, but very few with no signs of recovery. Again, looking at some benthos, this is for the mussels. This again is not new information, although these slides have been redone to be a little bit more clear. And also just to highlight that this sampling is taking place in 2025, so there should be updates to these maps once those samples are processed. There is sampling that takes place every year for mussels, and this is the size distribution of mussels over time at 3 sites in the Muskegon region, from the nearshore to the offshore. And they just show how dynamic the mussel populations can be in a very small area. In the nearshore, there's a lot of disturbances, and there's just complete variability to the size distribution of mussels at that site. At our mid-depth site, which is 45 meters, this is dominated by large mussels with very few signs of recruitment of new mussels into that population. At our deep site in 100 meters of water, you can see the population is dominated by small mussels that grow very slowly over time. And then finally, for the mussels, we like to keep track of the veliger density. Last year, we saw a huge spike in our near shore region and a little bit of one in our mid-depth region. In 2024, we saw very few veligers at any of our sites, and this was borne out through all of our sampling. Unlike last year, where it appeared that maybe we were back on the upswing, 2024 showed no signs of an upswing of veligers. In fact, it was one of the lowest years that we've had. So just a few thoughts to leave with. One is the importance of winter ecology. We had very high total phosphorus in our nearshore in the winter. We had very high zooplankton in the winter at our nearshore station. There's a lot potentially going on in the winter that we don't understand or don't think about. If we think about our marine counterparts, that winter to spring period is when a lot of phenology mismatches take place between phytoplankton, zooplankton, and larval fish. And so this is really a time period where we really probably need to be putting more emphasis on our research. Mysis are such an important part of the food web, especially with the disappearance of diparia. They appear to be persisting, but at a much reduced abundance. Part of that is they're concentrated in the deepest water depth, and that may be creating some sort of spatial mismatch with fish if those fish aren't in those deepest areas of the lake, but that's where the mysis are. Also keep in mind that there appear to be significant numbers of large mysis that remain on the bottom at night, and so we're missing those with our typical net sampling. And then finally, for veligers, we had relatively low abundance in 2024, but given their potential to be very important, we saw that with our secondary production. We saw that in our 2023 sampling. We really need to understand their role in the food web, especially because their numbers typically peak early in the summer and overlap with the time period with a lot of larval fish emergence. And so we need to understand how they're interacting with those larval fish as a prey resource and a competitor with other zooplankton. Thank you for your attention, and please feel free to contact me if you have any questions. Email me, and I will do my best to answer them or to elaborate more on any of these topics. Thank you.